Hi guys, so today we are going to go over plane geometry still. Specifically, we're going to talk about angles and figures, mostly triangles, but we'll go ahead and start on page 231. So, going through just some basic angles. Remember that a right angle is 90 degrees. Okay, they draw it usually like this, like with the little square showing that it's 90 degrees. A straight line is 180 degrees. For a triangle, they mean when you add up all the three angles here, you get 180. A quadrilateral, right, when you add all these, these four angles on the inside, you get 360. And then for a circle, right, all the way around, the center is also 360 degrees. So, go ahead and pause the video and we'll see if you can work through those next two problems. Okay, number 6, in the figure below, if AC is perpendicular to BC, which of the following represents the value of x? So perpendicular means they cross at a right angle. So I know that this right here is 90 degrees. I know that this is a straight line, so that is 180 degrees going like all the way across here. So I can set up an equation. X plus 90 plus y is equal to 180 degrees. They're asking what is the value of x, so I need to solve for x. So I'm going to go ahead and subtract 90 and subtract y. So I have x equals 180 minus 90 is just 90, and then minus y. So 90 minus y would be my answer here, so J. And then for the next one, in the figure below, x plus y is equal to what? So this 100 is actually right here. And if you remember, these two angles in the red are called vertical angles. They're right across from each other. And anytime you have vertical angles, those are congruent. Okay, so they have the same measure. That's helpful because for this triangle, I know that all three of these angles have to add up to 180. And so if I subtract that 100, I'm left here with 80 degrees between these two. So I know that when I add them together, I have to get 80. So there's my answer. Okay. Next page, parallel lines and a transversal. So anytime you have two parallel lines, which they'll have to tell you that they're parallel, and then you have a line that cuts through them. That's usually called a transversal. When you do this, you end up with some angles, right? They're just going to call them the four smaller angles, so I'm going to draw those in green, and then the four bigger angles, which I'm drawing in purple. These four angles are always congruent. So the four green angles are going to be the same measure. The four purple angles are going to be the same measure. Also, if you add together a green plus a purple here, you're going to get 180 degrees because that's just going to make this straight line right here. The vocab that you learned in geometry, alternate interior, alternate exterior, that usually is not on the ACT. It's more that they will give you pictures and then expect that you know these properties, right? That these four angles are congruent and that any two, if you add together the green or the purple, the green and the purple, you should get 180 degrees. So again, go ahead and pause, see if you can answer those next two questions, and then hit play when you're ready. Okay, so in the figure below, two parallel lines, A and B, are cut by line C. What is the measure of angle D? So right away I see the small angles here, these, and they're 45. So I'm going to label all these are 45. You can see D is right here, so it's the other angle, okay? So to find this missing angle here, I would do 180 minus 45, which gives me 135. So I know all these other four are going to be 135, which includes angle D. So my answer is H, 135. And then the last one in the figure below, lines P and Q are parallel. Transversal R intersects both P and Q as shown. What is the sum of the measures of angle A and B? So you can see A and B here are both the smaller angles, and I need to find the sum, so I need to add them together. I know that this angle right here is 160, and all the way across has to be 180. So again, I just take 180 minus that 160. That gives me 20 degrees. So both A and B are going to be 20. So when I add those together, I get 40. Okay, jump to next page is 233. Oh, so just properties about right triangles. I'm not going to go through this entire chart here. I think it's kind of silly, but big thing that I want you to remember with right triangles only, okay, so you have a right triangle here, is that the Pythagorean theorem holds true. So a squared plus b squared equals c squared. When you're labeling your right triangle, A and B have to be the legs, C has to be the hypotenuse, which is always the side across from your right angle, or the longest side, okay? If you can fill out the chart if you want to, right? You would just do the Pythagorean theorem to find your side lengths. I do want to point out a couple. This one is really common. If you have legs with 3 and 4, if you do the Pythagorean theorem, you end up with a hypotenuse of 5. This is called a Pythagorean triple, okay, 3, 4, 5. So if you see that 2 of the legs are 3 and 4, if you see a leg is 3 and the hypotenuse is 5, that one you can have memorized. It might save you some time. Also, anything that is like double this, so this one right here ends up being 6, 8, 10. If you double all those lengths, right, that's also going to be a Pythagorean triple, okay? So just common ones that you'll see. Sometimes you will, end up with a root. It's one of your lengths. That's okay. Okay. Next page, special right triangle. So this is not necessarily like required that you remember this pattern, but I do think that it's helpful. If you're trying to go for a higher score on your math section, like into the 30s, I would say that it is important that you know this because it's probably going to save you some time on at least 1 or 2 questions. So if you have a 45, 45, 90 triangle, so this one right here, the ratio of the side lengths is x, x, and then x root 2, okay? A 30, 60, 90 triangle looks like this. Your ratio of the side lengths is x, 2x, and then x root 3. Okay. If you just want to fill this in, the measure of each angle in an isosceles right triangle, so that's the one on the left, that's 45, 45, 90. The measure of each, let's see here. Measure of each angle in an equilateral triangle. So equilateral is where they're all 3 are the same length. That is going to be 60 degrees for every angle. So then how would you find the height of an equilateral triangle? So the height would be here. So if you split this, then this would turn into a 30, 60, 90 triangle, right? That would still be 60 here, 90 would be at the center. This would be 30. And then you could use your ratio, your special ratio to find your answer. A lot of times when they talk about equilateral triangles and they ask about the height, that's what they're wanting you to do, okay? So again, pause this, see if you can answer those 2 questions below. Okay. In the right isosceles triangle below, what is the length of segment AC? So they're looking for this value here. They're telling us that it's a right angle. They showed us that, okay, angle B is 90 degrees. But they're telling us it's isosceles, and so I know that this side over here also has to be 4. I would also know that these 2 angles are congruent, but that's not really necessary in this one. So my setup here generally is this would be x, x, and then x root 2. Yeah, so actually this one's pretty easy. I know that x has to equal 4, right? So then down here, this is just going to be 4 root 2. So my answer is H. Okay. And I actually could have used the Pythagorean theorem also to solve for that one. 45, what is the length of segment BD in equilateral triangle ABC graphed below? So this is kind of what they were just talking about, where you split this, okay, and find the height. I know that, all the way across, all of these are all going to be 10. This is split down the middle, so I know that each length there is going to be 5. So my pattern here is x, 2x, and then x root 3. So I know that that height there is just going to be 5 root 3. There's my answer. All right. Good. Let's jump to page 248. A couple more practice problems with triangles here. So again, pause, see if you can work through these. Okay, 32. What is the area of an equilateral triangle with a perimeter of 24? Okay, so I'm going to draw a picture here. The area of this thing, let's see here. Oh no, what is the area? Okay, if the perimeter is 24. So equilateral triangles, all 3 sides are the same. I know the perimeter is 24, so I just need to divide that by 3 to get 8. And so I know each length here is 8. Now, it's asking for the area, which is 1/2 base times height. So I do need to go ahead and find the height. So the same way I just did. I'm going to split this up, 4 and 4. I know this is x, 2x, and x root 3. So I know that the height here is equal to 4 root 3. So when I plug that in, I get 1/2. My base, so careful because that's all the way across, which is 8. My height is 4 root 3. Okay, 1/2 times 8 is 4. So I have 4 times 4 root 3. So my final answer is 16 root 3. Okay. 49, an isosceles right triangle has a perimeter of 4 plus 4 root 2. What is the length of one of the legs? So I think with this one, probably the easiest way is to just start with your answers, do PETA, and see which one ends up giving us the right perimeter. So it's an isosceles right triangle. So that's a 45, 45, 90. So I know my pattern is x, x, x root 2. Each of the answers that they're giving me is a leg, so that would be the value of x. So for each one of these, and I'm going to start with the easy ones and see if that gives us the right answer here. So I'll start with 2. So this would be 2 plus, my second leg would be 2. The hypotenuse would be 2 root 2. Which would be 4 plus 2 root 2, which is not quite the perimeter that we're looking for here. If I go down to 4, because again that's easier, it'd be 4 plus 4 root 2, which would be 8 plus 4 root 2, which again is not what I'm looking for. So let's go back up and start here. So root 2, it'd be another root 2, and then it would be root 2 times root 2, which is actually, this right here would be root 4, which is just 2. So my answer would be 2 plus, and then there's 2 of these, so 2 root 2, which again is not right. I'm going to change colors here so I can see. And actually, I'm going to draw this one down here. So for C, I'd have 2 root 2 plus the same thing, 2 root 2 plus, and then it would be 2 root 2 times root 2. Okay, again, root 2 times root 2 is root 4, which is just 2. So this entire thing would just be a 4. So I would end up with 4 plus, and then there's a 2 root 2 plus another 2 root 2, which is 4 root 2. And is, yeah, good. Finally, that's what we're looking for. So that one is C. Okay. That one's kind of tough. All right. Okay, good. Similar triangles. So similar triangles, or just similar shapes in general, remember, are the same shape but different sizes. Their angle measures are the same, so the ones that match up are going to be congruent, and then their side lengths are proportional. So maybe you double, right, every length to find your new length, okay, or maybe you triple or whatever it is, but they are proportional, all right? So for 14, in the figure below, if triangle ABC is similar to triangle DEF, then what is the length of side ED? So also when they name these, the order matters because they're telling you which sides match up. So side AB is going to match up with side DE because those come first. Okay. Side BC is matching up with EF, which is kind of obvious, and then that means that those last sides have to match up. So when I write an equation here, I'm basically just going to set up a proportion. Okay. So I'm going to use this lower triangle here. They give me all three sides, and then the one on the right, they give me 15, and then I need to figure out what I'm looking for, side ED. So I'm going to call that X. So here. So it looks like I need to use the blue and the green, because those are the two things that I have over here. So when I set this up, I'm going to say X over, so I need the blue. So over here in the second triangle, the blue is 8. Equals, and then 15, back to my first triangle, which is green, over 10. Okay, so then I can set up that equation. So notice that on the tops here, those are both coming from the same triangle, right? And the bottom is the second triangle. They match up correctly here. So I can do the cross multiplying here, right? Let's see, so 10x is equal to 120, and then divide by 10. So you get x equals 12. Which, you know, you can probably eliminate a couple of these, right? If you weren't sure how to do this one, this may be one you could have ballparked and kind of estimated what that length should be. Last one of these. So anytime you see a triangle built into another triangle like that, that's a clue that these are going to be similar triangles. Okay, so this smaller one here, and then this bigger one, the total there. Okay, so in the figure below, line segments EF and GH are perpendicular to segment DH. If EF is 10 and DE is 26, DH, so all the way down here, is 36, what is the area of triangle DGH? So I'm looking for the area of this big triangle. So over here, that's what my goal is, to try and find this area, 1/2 base times height. I know that, I don't know what the base is, but I know the height is 36. So then, I need to figure out what is this base right here. Okay, so again, I can see that I have some similar triangles, and I can go ahead and find some missing parts in order to find the base. So I know that the base of the smaller one is 10, so I have that matched up. But then I don't have two matching side lengths with the smaller and the bigger triangle with what I have given here. So what I'm going to do is actually going to use the Pythagorean theorem for the smaller triangle and solve for this piece here. So off to the side, I'm going to have 10 squared plus b squared equals 26 squared. Because again, that's going to give me this missing piece, which I can use to then find my base. So 100 plus b squared equals, let's see here, 676. Subtract 100. So b squared equals 576. And then take the square root, and I get 24. So I know right here, this side is 24. So now I have what I need in order to solve for my base, right? So I can set up my proportion. 10 over b is equal to 24, so this length here over the total length here, which is 36. So 24b equals 360. Divide by 24. It gives me 15. So then now I can finally go back and plug it in over here. So 1/2 times 15 times 36 gives me 270 for my area. All right, good. And then last, jump over to page 250. Okay. In the figure below, points A, C, and B are collinear. If angle ACD is 30, CAD is 70, and BCD is isosceles, what is the measure of angle BDC in degrees? So I'm looking for this missing angle right here. Okay. They tell me that this triangle is isosceles, so actually I know that these sides are the same, which also means that these little angles are the same. So what I'm going to do here is actually use the fact that this is 180 and subtract the 30 off. That will tell me that this little guy is 150. And then I know for this triangle at the bottom here that they have to add up to 180 and that these have to be the same. So if I call those x, then I would have x plus 150 has to equal 180. So 2x plus 150 equals 180. Subtract this off. And then divide by 2. So x has to equal 15. That might be one, honestly, that you could ballpark. That angle's so small, I think it's obvious that it's smaller than this 30 right here. So there's only one answer that's smaller than 30, so it has to be 15. We've kind of talked about, which angles here are congruent. So it says, in the figure below, line A is parallel to line B, and line C intersects both lines A and B. Which of the following statements could be false? That little thing means congruent to, so it means it's the same measure. So it says L is congruent to N. Those are the two smaller angles. They have to be the same, so it's not possible for that to be false. M is congruent to P. Both of those are the bigger angles, so they have to be congruent. L plus P equals 180. That's the small plus the big, so it has to add up to 180. K is congruent to N. K and N, those are both the smaller angles, so that has to be true. L plus K equals 180. Okay, that's the small plus the small. That is not necessarily true, that it has to add up to 180, so that is actually the correct answer. All right, in the figure below, a regular hexagon lies on a line. What is the measure of the indicated angle in degrees? Okay, so a couple things that you could do here. One of the properties is that if you look at every exterior angle, so if you extend all of these lines here and you look at these exterior angles, okay, and I'll draw where the curves are, those always have to add up to 360 degrees. And so because it says it's a regular hexagon, that means that all the side lengths are the same, which means all of these angle measures are also going to be the same. What you can do is just take that 360 and divide by the number of angles that we have. So 1, 2, 3, 4, 5, 6. Okay, divide by 6, and that gives us the 60 degrees. I would look back if you were not sure, if it, anytime they ask about inside angles, you're going to use that formula, n minus 2 times 180. That will give you the sum of the interior angles. You could also use that to find this exterior angle, right, because this is a straight line. Okay. Last thing, carving it up. So sometimes they'll give you weird shapes that, don't have a basic formula for area or whatever because they're weird looking. So what they say is to cut it up into shapes that you do know how to find the area for. So just by looking at this, because I know I'm going to try and find the area here, I can cut it up like this into 3 rectangles, right? The question is, what's the area of this figure? So right away, this triangle right here, I have the dimensions I need. This is 4 by 11, so the area, I multiply those together, is 44. Okay. Same thing down here with this triangle. This is a 2 by 4, so this guy is 8. And so then the last one I need to figure out, because they don't give me everything I need. This is 3 going across the top here, but this length I don't know. The total is 5. Down here, this is 2, which means that this guy has to be 3. So a 3 by 3 is a 9. So then I just need to add up those 3 areas, which gives me a total of 61. Okay, and then the last problem here, what's the area of the trapezoid below in square centimeters? So 2 options here. If you have the area of the trapezoid memorized, you can use that, okay, which I'll use in a second. The other way, though, is I can break this down into a rectangle and 2 triangles here. This would change to 18, right? All the way across is 30, so I would need to subtract off that 18, which would give me 12, which leaves me with 6 on either side here. And then I could find the area of the rectangle and the 2 triangles. It's nice because they give me the height, right? The height is 8. So area of the rectangle would be 18 times 8, which is 144. Each triangle would be 6, or 1/2, 6 times 8, which is 24. So then I would just need to add those 3 things together. If you wanted to do the formula for the area of a trapezoid, it's 1/2, what is it? Base 1 plus base 2 times height, I believe. So in this case, it would be 1/2, and then you'd add your bases together, so the bottom and the top, so 18 plus 30, and then your height is still 8 here. And that does give us the same answer. Either way, you should get 192. All right, guys, that's it for today. Thanks.